If you did really, really well on this snapshot, please sit quietly and politely and allow those that did not to absorb some information. There's also a pretty decent chance, provided that you used your time wisely yesterday, that you've gotten better um, between when you did this and now, provided again that you were working hard yesterday. So there's a chance that you already kind of look at it and go, yeah, now I know how to do this, but there's also a chance that you don't. So let's just take, I don't know, 10, 8 minutes, something like that, 6, 7 minutes, something like that. So the first problem and the second problem, we are told to do them by factoring. So that's what we're going to do. This type of factoring is pretty straightforward. We want to just take this thing and break it down into the shells like this. Listen, I'm not going to take points off for this, but you guys really should form the habit, please, of keeping the equal 0 there. I'm going to say that again. You really should keep the equal 0 there. Okay, it's what makes this work. It's not worth red ink or losing points over. It's just more proper to state that these two things multiplied make 0. Oh, I'm looking at the wrong thing. Holy, thank you. I'm looking at it's really not the same thing. It's 4x squared and then the 3. I'm sorry, I was looking at the wrong document. I apologize for that. Thank you. Golly. Boy, look at that. 755. We're already screwing things up. So we go into this problem not knowing if it's this template or if it's this template, right? It's just kind of factoring 101. So we have to try some stuff. We do know, because of the 10 in the back being a minus, that there is one of each sign. So regardless of which template we choose to use, we're going to have to bear that in mind. That will not change. Like, you don't get to say, well, I'm going to try 2 minuses. Like, that's just not up for debate, right? They have to multiply to make -10. They being the numbers that we're about to conjure up, right? Chances are it's going to be a 5 and a 2. And I don't want to put the 5 here because it'll get too buffed with the 4 when I check it and multiply it out. So if 5 and 2 are to work, then I'm going to put them in their proper places. I want to weaken the 5 and strengthen the 2. That's kind of how this logic works. And then you always have to check to see if what you did works. And really, if it doesn't, that's okay. It just means you have to try again. So what I mean when I say check is I mean to check these. You've seen me do this probably 200 times by now. You multiply those and you get -8x. And then you multiply the 2 in the center and you get +5x. And then you add those together and you should get, if it's correct, you should get the same thing as what's in the middle of the problem, which you do. This is not a factoring problem. It's a quadratic equation that we use factoring to solve. So this is not the end of the problem. These are just the components that we'll use then to find what we care about, which are the solutions. So we have to make this red box equal 0, and the only number in the world that could make that red box equal 0 is a -5, but it has to be divided by 4 because there's a 4 in place or in front of the x, right? And then we have to make the green box equal 0, and the only number in the world that could zero out the green box is a +2. So these are the solutions to the equation. The factoring is just the work. It's the means to the end, right? Any questions about that? Okay, problem number 2. I think I'll keep this here so I don't look at the wrong thing. I moved some things around on you just to make sure that you didn't panic or anything like that. So a general, you've heard me say this also, a general guideline here is you should not let this number go negative. So even though some of you have this obsession with putting x's on the left, it's really better in this case to move the 18 across there so that the 2x squared stays protected. So I'm going to have my 2x squared stay, my 9x is going to stay plus, my 18 is going to switch to minus, and let the games begin. And as I've said, if you don't like the equal 0 to look like that, you could just swap it to the other side. It doesn't matter. Okay. So this one is actually, once you settle it out, it's actually a simpler factoring problem just because 2, the number in front, is a prime. So there's no possibility for multiple templates. It's got to be a 2x and a 1x. The signs have got to be, again, because of the minus on the 18, the signs have to be one of each. And now it's just a hunt, right? I would always start with the closer factor pairs of 18 or 118, 2, 9, 3, 6. I'm going to start with the 3, 6 because they're closer. It just works more often than not. So that's where I go with it. Um, and if I put the 3 here and the 6 here, something kind of nice happens, but it's just not quite nice enough. But it's progress because these make minus 12x, and then the ones in the middle make plus 3x. And if you know how to add and subtract, you know that those equal minus or negative 9x. And that's not quite what we wanted, right? We wanted a plus, so what do? You just switch your signs. If you get the right number with the wrong sign, then you just switch your signs. And so the plus 3 and the minus 6 should be a minus 3 and a plus 6. And then the dynamic shifts over. And again, that's not the end of the problem. This is not a factoring test. This is a solving quadratic equations test. The factoring is just the means to get there. So what makes the red box equal 0? Yeah, positive 3 for sure, but we have to again divide it by 2 because the 2 in front of the x says so. And then there's a green box that we have to make equal 0, and that one is just negative 6. No division necessary on that one because there's no number in front of the x. So that's going to be the first half of what I expect you to know how to do is factor and then solve, right? Well, I mean, arrange it, then factor it, and then solve it. Any questions about the factoring ones? All right, so the completing the square is the one that, and I think I might have jumped the gun on this snapshot. I really, in hindsight, I wish maybe I'd given it to you at the end of the hour so that you would have had, like 30 minutes to get better at it, because I do think it came at you pretty quick. But for those of you that did well, good job, good learning, good like quick absorption of a skill. So this one is x squared plus 8x minus 56. And it's just a set of steps. It's a sequence of steps that we have to follow. What is step one? Speak to me. Yeah, we don't want a number right here. We want that to be an awkward like landing pad void for where we're going to complete a square. So we first want to get that 56 to the other side, and we want to move the equal sign over so that we have room here to put a magic number. And when you move the 56, he becomes a positive 56. And then this is where the repetitive algorithm just saves the day for you. And it's just, I want to say maybe it's a 3-step process. Step 1, take half of plus 8, which is plus 4. Step 2, square that. Step 3, add the answer here and here. Those are the 3 steps. You just boom, 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 like back to back to back every single time. And the reason we do that is because we just completed a square. This thing that I'm underlining is called a square. This is how I started the lesson Tuesday, I think. And it's called a square because when you factor it, which you should know how to do, it factors into this. And it just so happens that the numbers are both 4, right? If you're willing to write this down, what I just circled in green, you never have to actually know how to factor. You can bypass this. You could teach this to a student who doesn't even know what factoring means because you could just teach them to repeat the following steps. You just put this, and then you take that purple number up there, plus 4. You're done. I say you could see what I mean. You could teach that to someone who never has factored in their life. You're factoring, you just don't have to really know that you are, which is kind of fun. And then on the right side, you got to do some math. 72 is the answer to this. And then we square root both sides. So we get x plus 4 equals, and we write the positive negative sign before we even begin. That's the moment when it has to show up. If you put it before, you're going to lose points. If you wait, you're going to lose points. It has to happen the moment you take the root, okay? For reasons, again, that I discussed on Tuesday. The square root of 72 got some of you guys because what you commonly think about is 9 and 8. That means someone did their job, right? Whether it was a parent or an elementary school teacher, if you think 9 and 8, that means someone did their job. You should send them a card and say, thank you for teaching me my times tables. The trouble with 9 and 8 is that it's going to leave 8, which is not dead. So just because we know our times tables doesn't mean we use the first thing that comes to mind. The breakdown of 72 has got to be 36 and 2, right? You could do 9 and 8 if you promise to then take the 8 and subsequently break it down again. But ain't nobody got time for that, right? So we'd rather do this all at once. The square root of 36 is 6. So my right side says 6 times the square root of 2. What's the last step? Because we're not done yet. Yep, get the 4 to the other side. And just remember that generally what we're going to do is we're going to tuck it right there. Not putting it there doesn't make this wrong. It's just what we do. It's just math is a language, and like any language, you want to speak it properly. And so generally mathematicians will put uh, the mover guy in the front, because we like to say it the same way every time. So it's x equals -4, and that's no longer called a positive negative sign. We now rename him as a plus or minus sign. Okay, if it's a verb, if it's got something in front of it, it's an adjective if it does not. Any questions about that process? Bless you. All right, the last one on here, and then I'll shut up and give you what we're doing today, is this. So this problem, I'm testing a couple things of my students. Number one is obviously I want to know if you can complete the square. But prior to that, I need to know if you can do something else. What is it? What's wrong with this problem? Like it's broken. What's wrong with it? Yeah, it's got a negative in front of the x squared. So we have to be cognizant of the fact that like we want things to be a certain way to make our lives easier. So I don't want to leave the x squared with the negative on it. What I want to do is put the x squared on the side where he'll be positive. So that means in this case, I say x squared, you're going to go over there. And normally I would say 41, come along for the ride, but for reasons that I think you might already know, I'm not going to do that. If I move the x squared across and I leave the 6x where he is, and I leave the 41 where he is, this is now ready for completing the square. To be ready to complete the square, your format should be x squared in linear term on one side, constant on the other side. And some people would look at that and say, that's not what I want it to look like. And that stuff like that used to bother me. And anymore, I just embrace anything that's going to help you be successful. So take your x squared and your -6x and put them over here if you like it this way better. And then just keep your, like, you know what I mean? Left becomes right, right becomes, it's fine. And that way there, it looks like what you want. And now the algorithm kicks in, the 3 steps. What's half of -6? And don't say 3. It is -3. And I have seen several instances already of when not putting that sign is detrimental. So when I say what's half of -6, we want to say -3 because that number is going to be critical here in a second. What's -3 squared? +9. So I'm going to add 9 to both sides like this. The reason putting the minus sign, I'll put a little yellow arrow pointing to it. The reason that is so critical is because, as I was saying earlier, even if I don't know how to factor, I could say I'm the worst factorer in the world. I suck at factoring, but I can still do this because all I have to do is that. And I don't have to do any math at all. I just have to take this number, this -3, and just pop it in there. And look, I factored without even knowing I was factoring, right? So that's why that sign is so critical. And then we're going to square root both sides and we get x -3 equals positive negative. Write the positive negative before you do anything else. And again, we got to go off to the side. You have to be good at this, and I'll make the same offer that I made before. If you're not good at simplifying square roots, I'm not going to give the whole class an assignment on it because not everyone needs it. But you're big kids, and if you don't know how to simplify square roots with 100% perfection, you need to come let me know and I'll help you and I can give you some practice problems. You know, that's a big kid thing to do, is to say, can I have some practice on this? All right. What does 50 break down into? Root 25 and root 2. And what's the square root of 25? So my 5 root 2 will sit over here. And then the work is done. I just need to get that 3 out of there. So when I move him, he becomes positive. And I just attach. And again, this goes from being called a positive negative sign to being a verb now. It's called a plus or minus sign. So it's 3 plus or minus 5 roots of 2. Got it? So I did learn some stuff from the snapshot. I learned that I probably gave it at the wrong time. I also learned that about half of you had no idea how to complete the square. And about 15% of you still don't know how to factor, which is a little bit interesting. So listen, I can help you, but you've got to acknowledge what it is you suck at. Um, right? I mean, realistically, there are those that would say that I should just seek out every kid and find their weaknesses and tailor my instruction, but that's not realistic throughout the day with 114 kids or whatever, right? You guys strap on your big kid boots and like, hey, man, I suck at factoring. Can you give me some practice? Yep. Or, man, this completing the square is killing me. Can I get some more? Yep. Like, I'm in it, man. You just got to let me know, okay? Any questions at all? All right, so today I have a practice quiz. You may work on assignments 23 and 24 if you're still going on them. You may also work on the practice quiz if you're ready for that. Okay, there are six on the front, six on the back. So the first six are obviously factoring, the six on the back are completing the square. Any questions about that? All right, then.